Imagine waking up one day and realizing you are no longer on Earth. The ground beneath your feet feels different. The sky above you looks unfamiliar, and even the way your body moves suddenly changes. That is not science fiction. It is what would happen if you lived on different planets in our solar system. Each world has its own gravity, atmosphere, temperature, and pressure, and your body would be forced to adapt in surprising ways. If you lived on Mercury, the closest planet to the Sun, your body would face extreme condition. Days would be scorching hot and nights freezing cold. Because Mercury has almost no atmosphere, there is no protection from solar radiation. Over time, your skin would be constantly exposed to harsh rays, making it vulnerable to damage. The gravity is only about 1/3 of Earth's, so your body would feel lighter. You would be able to jump much higher, and your muscles would not need to work as hard. But this reduced effort would slowly weaken your muscles and bones, making your body fragile over time. Now imagine Venus, a planet where the atmosphere is thick and crushing. The pressure is so intense that it would feel like being deep under the ocean on Earth. Your body would be compressed from all sides. The heat is extreme enough to melt metal, so survival in such conditions would be impossible without protection. If hypothetically adapted, your body would have to evolve extremely strong structural support just to resist being crushed. Breathing would also be impossible, as the air is mostly carbon dioxide mixed with toxic clouds of sulfuric acid. Mars presents a different kind of challenge. The gravity is lower than Earth's about 1/3, so your body would become lighter. At first, you would feel like you are floating with ease. You could jump higher and run faster, but over time your bones would lose density, becoming weaker. Your muscles would shrink without constant resistance. The thin atmosphere would make breathing difficult, and your lungs would have to work much harder to extract oxygen. Without protection, your skin would be exposed to radiation, which could increase health risks. Your body would slowly become more delicate and less suited for physical strain. Each planet has unique conditions like gravity, temperature, atmosphere, and pressure that would directly affect the human body in different ways. Every planet in our solar system has its own unique environment, and these differences would have a direct and powerful impact on the human body. Gravity is one of the most important factors because it controls how heavy or light your body feels. On some planets, gravity is much weaker than Earth's, which would make movement feel effortless at first, almost like floating. You could jump higher, run faster, and lift heavier objects with ease. However, this freedom would not last forever. Over time, your muscles would not need to work as hard, and because they are not being used with full resistance, they would slowly begin to shrink and weaken. Your bones would also lose density because they would not be supporting the same level of weight as they do on Earth. On the other hand, planets with stronger gravity would have the opposite effect. Your body would feel extremely heavy, as if a powerful force is constantly pulling you downward. Even simple actions like standing, walking, or raising your arms would require great effort. Your heart would have to work harder to circulate blood throughout your body, and over time, this strain could change the structure and strength of your muscles. These constant adjustments show how deeply gravity shapes the human body and how even small changes in it can transform physical ability, endurance, and overall health in dramatic ways. Low-gravity planets, Mercury, Mars, Saturn would make the body feel lighter at first, but would gradually weaken muscles and bones over time. Low-gravity environments would create dramatic changes in the human body over time, especially in how muscles and bones develop and function. When a person lives in a place where gravity is much weaker than on Earth, their body no longer needs to work as hard to support weight or perform daily movements. At first, this may feel exciting and almost effortless. Walking becomes lighter, jumping becomes higher, and even lifting objects feels surprisingly easy. However, this reduced effort begins to have hidden effects on the body. Muscles, which rely on resistance to stay strong, start to shrink because they are not being used at full capacity. This process is called muscle atrophy, and it leads to a noticeable loss of strength and endurance over time. Similarly, bones also begin to weaken because they are not constantly supporting the full force of gravity. On Earth, bones are naturally reinforced through regular pressure and movement. But in low gravity, this stimulation decreases, causing bone density to reduce gradually. As a result, the body becomes more fragile and more prone to injury. Even the heart and blood circulation system may be affected, as they do not need to work as hard to pump blood throughout the body. Over long periods, these changes could make it difficult for a person to return to Earth without facing serious physical challenges, showing how strongly gravity influences human health and stability. High-pressure environments. Venus, Jupiter, would put extreme stress on the body, making movement difficult, and potentially crushing the body without protection. Living in a low-gravity environment does not only affect muscles and bones, but also brings gradual changes to the entire functioning of the human body. When gravity is weaker than on Earth, the body experiences a constant reduction in physical resistance, which means everyday movements require less effort. At first, this might feel like a relief, as walking becomes easier and the body feels unusually light. However, the human body is designed to adapt to stress, and without that stress, it begins to lose its strength. The muscles that are normally used to support posture and movement start to weaken because they are no longer challenged by weight. Over time, this leads to a noticeable decrease in stamina and physical endurance. The skeletal system also becomes affected because bones rely on pressure to stay strong and dense. Without regular gravitational force, bones slowly lose minerals, making them more fragile and less capable of handling impact. Even coordination and balance can be impacted because the inner ear, which controls spatial awareness, adjusts to the lighter environment. Blood circulation may also change, as the heart does not need to pump as strongly as it does on Earth, which can lead to further physical imbalance. These gradual changes highlight how deeply human biology depends on Earth's gravity and how even small shifts in that force can reshape strength, health, and overall physical stability in significant ways over time. Extreme temperatures and atmospheres on planets, like Mercury, Venus, Uranus, and Neptune, would make survival impossible without special adaptation or technology. High-gravity environments would place extreme pressure on the human body, creating conditions that are far more demanding than anything experienced on Earth. In such settings, every movement becomes a challenge because the body feels significantly heavier than normal. Simply standing upright would require continuous effort, as the force pulling everything downward would be much stronger. Walking would feel slow and exhausting, and even lifting the arms or turning the head would take noticeable strength. Over time, the cardiovascular system would be forced to adapt, with the heart working much harder to pump blood against the increased gravitational pull. This constant strain could lead to fatigue and reduced endurance. The muscles would initially become stronger in response to the heavy workload, but prolonged exposure could also cause overexertion and stress on the body. The skeletal system would experience intense pressure, especially in the joints and spine, which could lead to pain or long-term structural changes. Breathing might also become more difficult because the lungs would have to expand against greater force. Even simple daily tasks would feel like physical exercise. Despite these challenges, the human body might slowly adapt over time by developing stronger muscles and denser bones. But this adaptation would come at a high biological cost. High-gravity environments clearly show how powerful gravitational force can reshape physical strength, endurance, and overall human survival capacity in extreme ways. Returning to Earth after living on other planets would cause major adjustment issues, as the body would struggle to adapt to Earth's gravity and conditions. Extreme temperatures and harsh atmospheres on different planets would create some of the most difficult challenges for the human body, affecting survival at every level. In extremely hot environments, the body would struggle to maintain a safe internal temperature. Sweating would increase dramatically as the body tries to cool itself, but in places with intense heat or toxic air, this process would be far less effective. Dehydration would become a constant threat, and the skin would be exposed to damaging radiation or corrosive gases. In contrast, extremely cold planets would slow down body functions, as low temperatures reduce blood flow and make muscles stiff and less responsive. The body would need to produce much more energy just to stay warm, increasing fatigue and energy consumption. Over time, humans might develop thicker layers of fat for insulation, but survival would still depend heavily on external protection. In atmospheres filled with toxic gases, breathing itself would become impossible without artificial support. The lungs would be unable to process harmful chemicals, leading to immediate danger. Even vision, hearing, and sensory perception could be affected depending on atmospheric density and composition. These conditions show that temperature and atmosphere are not just environmental factors, but vital forces that determine whether human life can exist at all. Together, they shape how the body functions, survives, and adapts, proving that Earth's balance of air and temperature is essential for human life.